Question number 4 is an area problem where we need to find the area of this area S. So S is a shaded region in the quadrant bounded above by the horizontal line, so y equals 3 here, and this line is 3 sine x, so 3 sine x here. And it's going to be bounded by this line here, k. Okay, so as we move this line k, we're going to get different areas because that point here is a fixed intersection point. So it tells you that k is between 0 and pi over 2. We should probably just make sure that we know that endpoint here. That endpoint is where the two graphs meet, so 3 is equal to 3 sine x. So sine x equals 1. So x is equal to pi over 2. And then 5 pi over 2, etc. So that looks like that endpoint is definitely pi over 2. Okay, so what we're looking for is we want to find out this area when k is starting at pi over 3. So we want to integrate this area from pi over 3 to pi over 2. So the area S, we'll call that area S, is equal to the integral from pi over 3 to pi over 2. And we need to find area, we need to find length times width. Okay, so this vertical length is going to be the distance between 3 and sine x. So it's going to be 3 minus sine x, sorry, 3 minus 3 sine x. And then we're going to multiply by the width, which is dx, and there's our integral. So at this point we have the integral to do. We can anti-differentiate this. So we end up with 3x minus, it's going to end up negative cos, so we're going to end up being plus 3 cosine of x. And that's going to be from pi over 3 to pi over 2 as our bounds. So at this point we just plug in. This is equal to 3 pi over 2 plus 3 times cosine of pi. Cosine of pi is going to be 0 minus 3 times pi over 3. Cosine of pi over 3, when we take a look at pi over 3, it's going to be here. So the cosine is going to be 1 over 2. So that's plus 3 times 1/2. And then I just need to simplify this expression. So this ends up being 3, I'll do the pi's first. So 1.5 pi minus 1 pi, so that equals pi over 2. 0 minus 3 over 2, so that becomes minus 3 over 2. So there's our answer. That represents some units squared. Okay, so the 3 marks for this is being able to write the integral, okay, anti-differentiating this, and actually working out the answer, the correct answer. Part B is, it says area S function is a function, and the rate of change is a function of k, and the rate of change is the area with respect to k. So first of all, S is a function of k, and the area, that function is an integral function. Okay, so it's the integral from the area from k to where it stops at pi over 2. And it's going to be the area, area function, which we've worked out to be this integral. Okay, so first, couple things that we have to be careful. Make sure that you are clear on the direction of the bounds. Okay, we are integrating from k on the left side to pi over 2, and this k is going to move, but we're integrating from left to right. Okay, so that's one thing. And we are now finding the rate of change of the area of S. So that means we're looking for S prime of k. Okay, so S prime of k is the derivative of this function. Well, the fundamental theorem of calculus states that if we differentiate this function, okay, we're just going to get the expression inside the integral. So this ends up being big x minus, and I'm just going to plug this in. So we're going to plug in our bounds here, and you have to be careful with this because, again, the direction of the bounds is important because notice that we're going to subtract this, right? When we integrate it, sorry, this is going to be s of k, so they're going to subtract this when we integrate it. So when we differentiate this, we have to remember that the derivative is going to be the negative portion of this because this will differentiate to 0. Okay, and this is going to differentiate to the negative of this expression. So it becomes negative 3 minus 3 sine x. Okay, and this is by the fundamental theorem of calculus. We go straight from here to here. This is the fundamental theorem of calculus. Okay, and by FTC we can go from here to here, but we have to be careful of this negative sign. So I'm just going to highlight that negative sign because the k is on the lower bound. That's our variable, so the variable is going to be on the negative part of that expression, not on the positive part of that expression. Okay, so that's one thing you have to be very careful of with this question. Okay, so then once I found the derivative, I have the derivative expression. It says find the rate of change. So the rate of change, okay, that's s prime when k is pi over 6. So s prime at pi over 6. I'm just going to plug pi over 6 into this expression, so I get negative sine of pi over 6. Okay, when I look at my circle again, sine of pi over 6 is going to be the root 3 over 2. It's going to be the long side over the short side. So then this becomes negative 3 plus 3 positive root 3 over 2. So there's my integral. Sorry, there's my derivative or my slope at k equals pi over 6.